All right, so the recording is started. Yeah, okay, that works. So we'll be going over the design for this practical and the reason why we should always do the design and focus a little bit on the design. So I know a lot of students think that the design is a waste of time because you have to do so much of things like algorithms and variables. But the fact of the matter is we're in a software engineering degree. Informatics is called Introduction to Software Engineering. Well, it was last semester. So you should be following software engineering practices in this semester, right? Wait, was it? Yeah, so basically, the software engineers like to design things because it allows them to make up for lack of experience when working with a specific kind of project. If you know how the design if you know how the project should work, you make a design and then you can verify with your client or with the assistants in the lab whether you understood the problem correctly. And this will allow you to not waste your time. It'll allow you to make an effective solution that wastes the least amount of your time and the least amount of our time as markers and assistants. So I'm just going to screen share a version of a design I made for this quickly because I made it so that I could just explain how to do a proper design. It's very basic and it's just so that you guys can understand the design. I just need to find it again. What is it called? What is it called? All right, here it is. It's in Word. All right, let's just get this quickly. Get the screen shared. Quick. All right, so I will be doing just a quick overview of how the design should work, and then we'll go on to the actual practical. If you have any questions throughout this, please feel free to raise your hand and then talk to me with your mic, or send a message in the chat and just raise your hand so that I'm aware that you are actually you actually have a question to deal with. All right, so let's just get this going. All right, can everybody see that? Please raise your hand if you can see that and it's a good quality. Just making sure. Cool, you guys can see that. That's great. All right, so basically, important thing to have is always have your information on your design. This is in just a general thing. Never make something and then don't put your name on it, right? Always want credit for stuff you make. Always want marks for things you make, right? I put this in red here. You're not supposed to have this in your design. It's just a reminder to you guys who might be watching the video at a later stage, or if it's something that you really need to remember, right? The point of a design is not only to make sure that you're actually solving the problem given, but that you're doing it in the most correct, time-efficient, resource-efficient way possible. Now, why is it important that we make sure we're solving the actual problem that we were given? A lot of kids gave me practicals in the last one where you guys asked for inputs for sequence 1 and 2, and that clearly wasn't part of the instructions. So you guys wasted a whole lot of your time and a lot of the markers' time now, basically doing stuff that you weren't supposed to. So just make sure you're solving the problem given, and make sure you're doing it in the most correct. Now, when I say most correct, this means it needs to be user-friendly, it needs to be easy to mark, it needs to be easy to deal with, and it needs to be without mistakes, right? So if you start off without a design, you're most likely going to make mistakes, particularly with this recursion thing. Recursion is slightly difficult to wrap your head around if you're not used to it, okay? So time efficient, obviously doing a design really cuts out a lot of time when you get to like doing bigger projects and group projects. If you design when you're doing a group project, your group will work much faster, they'll work much more efficiently, and they'll work much more correctly, right? For the inputs, the only input you needed this time was the term number that you were trying to calculate for the parent sequence. The outputs was basically the product value of sequence 1, the product value of sequence 1 using recursion, sequence 2 using iteration, sequence 2 using recursion, and the nth term. Need events and actions. Remember, events are things that the user does, actions are how your program responds. Right? The interface, a key thing here, right? A lot of you kids didn't label this, didn't label everything. Make sure that everything is labeled and it's as user-friendly as possible. I don't know what sec1 iter means, right? label your button with the name your button, and then put text over it saying sequence 1 iterative, and tell me what sequence 1 is, right? Because as somebody who's just using your program or marker, and even though I know what problem you were solving, sometimes it was very hard to understand what the heck you were doing when it comes to interface, right? So just make sure of that. As you can see, I designed it to have text boxes here. Reason being is I want to show you guys something really cool where I actually display the values. That's a little bit extra, but it's a good way for you to look at how whether you understand recursion and whether you understand iteration, right? For my variables in the way I'm going to do it, I didn't have any data structures and I only had local variables, right? A lot of you guys said the same thing where you actually said local variables. Oh, there's a question, I think. Let me go check quickly. Is this a question? The input one more time. Sure, I'll go back to the input now. Here we go. Input. Is there a question with regard to this? Sorry. Okay, thanks. All right, cool. No problem. Going back down again. Remember, for your interface, please label everything. If you want to make a nice little one that's easy to work with and takes you like 5 minutes to make, just go to Lucidcharts. Every student should have like a free account where they're allowed to make like 10 documents or something like that. Just try and make an account there, or even try and make a free account on Lucidcharts, or use something like Visio or something that allows you to properly design a mockup. Look at the, like you see here, you can actually see these buttons. You can see that this is a form. It's much easier to do than to just draw it using Word or Paint, right? So algorithm, right? I'm not going to put an algorithm here. You guys should know how to do algorithm. You've been doing it for the longest of time. Just remember, I'm still seeing people dropping in equal signs, right? Make sure the only time you're using an equal sign in your algorithm is when you are checking conditions. So in your if statements, in your loops, etc. like that, right? So then we've got test data. One of the things that I really recommend is you give 3 sets of test data, right? Reason being is it shows that you've tested your program thoroughly, and the chances of us testing it and breaking it are much lower. Remember to use basically logical test data, right? So like with the one practical where you guys work in the millions for the liquor store stuff, test with tens of millions of rands. Test with stuff that's realistic value so that you can see when it crashes, right? That's an important thing. So now that's all for design, basically, just like the main points of a design. Is there any questions regarding that before we will go on to actual code? Please let me know. If not, I can just go on. Or do you guys have any questions regarding to the actual practical? Should I go over the question paper quickly, just so that you know what is happening? If, as far as I remember, is basically just do the one sequence in iteration, do the one sequence, the same sequence using recursion, do the next sequence using iteration, do the next sequence using recursion. Each sequence should have 2 buttons. Is it term 13 or 14? Is it term 13 or 14? Term, if n is equal to 13. That's a very good question. That's a good catch, actually. We'll test that, actually. Let's assume you made a mistake in your test data, right? Or you made a mistake in your actual design. That's more than okay. You're allowed to submit a design that varies from your program, right? This is because, yeah, we'll do the sequence now on the encode. But basically, the reason I'm saying you're allowed to deviate from your design is because when you design, it's just to root out all of the small mistakes that you could possibly make. So what you want to do is you wanna try and limit the amount of mistakes you make and limit the time that you spend on debugging, right? Because debugging takes a long time with bigger projects. So if you decide to improve something, like let's say you improve the interface, right? That's more than okay. That's 100% okay, actually, right? So you should be doing that. You should be improving as you go through stuff. So I'm just gonna start up Visual Studio quickly, and then I am going to share Visual Studio. All right. All right, can you guys see Visual Studio? Please raise a hand if you can. It should just be a blank Visual Studio right now. All right, cool. Thank you so much for that. Let's go into the code, right? So I did a little bit of prep this time because I'm on a slightly tighter schedule than normal. So what I want to do is I want to just go through it as fast as possible, but please stop me. Tell me if you don't understand what's going on. Tell me if you have a question. You're more than welcome to have a question. Right? How do we know where to declare both x and y in recursive? Okay, so we'll get to that one, right? Basically, you're asking me how many parameters, if I understand your question, like how many parameters you're supposed to send, was supposed to declare. Yes. Okay. Well, that just depends whether you know about how much you know about the function and the sequence that you're dealing with, right? So, for example, most cases you know where to end because that's going to be your there's a word for it. There's a word for it. Base case, right? It's going to approach your base case, and that's where your function is going to stop, right? So if you know where it ends, all you need is where it starts. So you'll need to know where it ends and where it starts for some functions that might be continuous, right? That can go on into infinity. Like for example, the 7, the second sequence. Actually, if you declare that as integers, it can go on forever, right? You'd have to basically choose where it starts and where it stops, being the coder and knowing the limits of your problem. That's also another reason why design is important. So you know the limits of your problem. Does that kind of answer your question? Yes, no, maybe? It might become more clear in the code. So if it doesn't fully answer your question, you're welcome to ask me again after I've shown you the second sequence, right? Just hold on to it for now. Is that all right with you? Okay, cool. No problem. Back to Visual Studio we go. Let's make that a big screen. Go to the form, right? What's going on? Oh no, I've done something wrong. Okay, I'm just gonna stop showing this and then I'm gonna quickly open up again. Well, my bad. I think I did something wrong with opening Visual Studio. If you have this problem, all right, it's just try and location in your file structure and try and open it using Visual Studio manually by double clicking the solution, because that's what the marker will try and do, right? So I'm just gonna see, yeah, okay, this time it works. Let me start sharing screen again. Okay, can you guys see that? Please raise hands if you can see that. It should show you my form. You should be able to see my form. Okay, cool. As you can see, okay, cool. Thank you very much. That's great. As you can see, basically, I did my form from my design. I put just a simple label at the top detailing what sequence 1 is. Then I put a button for sequence 1 iterative. I put a button for sequence 1 recursive. I've detailed what sequence 2 is. I put a button for sequence 2 iterative and a sequence 2 recursive. And I've got a label saying doing parent things because I'm lazy and I don't want to say calculating the nth term of the parent sequence. It's too many words. Right? Can you please zoom a bit? Sure thing. I can definitely zoom a bit. If well, I guess I think I can try. No, apparently I can't zoom a bit. Let me try and get the magnify thing for you, just so you can see the form. Is that a bit better? Yes, no, maybe? Raise hand if better, please. All right, cool. So just take a look at it because I'm not going to show this. I hate working with the magnifier, but I will show it more if necessary. All right, so just take a look at that. Cool. Let's go see your questions. You got 3 questions. No, okay. Let's. I don't know why it's such a problem. Your main display to 250%. Mm. All right, well, to be honest, the form isn't really that important. If I get a chance, I will show it to you again. But do you mind if you go to the code quickly? Is that all right with you guys? Raise hand if okay. Raise. Okay, cool. Let's go towards the code. Because I think that's the most important part, right? Just actually doing the stuff. Magnify, RFT, Blackboard, zoom your stuff. Oh, you can zoom on Blackboard for you. Okay, that's pretty cool. I didn't know that. Interesting. All right, let's go to the code. All right, so you guys should be seeing my code right now. Remember your option statements, right? Option statements are really important. Add all your details always, right? If you don't do this, at some point we will start taking away marks, okay? So for my details, I just put San Saturday Tut on how to recursion, because that's what we'll be doing. Never forget your option statements. That's important. If you forget this, we will put them in, and then when it crashes, which it will, we will take away marks from then on, right? So button 1 was sequence 1 in iterative, right? As you can see by the name here. Okay, so let's talk about quickly how to approach solving a problem iteratively. Essentially, what we're trying to do is we're trying to find out what the relationship is between a term number and the term, right? So basically, if we look at the sequence here, right, we've got 1, 4, 9, 16, 25. We've got 1, 2, 3, 4, 5, right? So we know that 1 and 1 is the same. 4 and 2, well, 2 is the square root of 4, 3 is the square root of 9, 4 is the square root of 16, and 5 is the square root of 25, right? So just trying to look at that relationship to get an idea of how to deal with it, because that'll enable you to better deal with to find a way to solve the problem, right? Also, knowing the amount of terms tells you how many times you have to loop through something, right? That gives you something we call a control variable. I'm sure you guys know this. You guys did a lot of loops back in the day. When you learned about while loops and for loops, you had a whole practical dedicated to it. So I'm not going to go too much in depth there. I don't want to waste anybody's time or bore them to sleep early on the Saturday morning. Now, a lot of people asked if it should be a for loop or a while loop, right? Either one, they both just trying to repeat something, right? So all that matters is that you repeat something the right number of times. Okay, this was just a basic setup to save some time, because I felt like I wouldn't get through this whole practical if I didn't do a little bit of setup, and I wouldn't be able to explain everything as well as I should, right? The only reason I have these things as strings is because I want to display them in the rich text box that I put up there, right? You'll notice that I send the sequence there, right? And the sequence is by ref. This is because I actually want to show you guys the sequence. I want to display the sequence as we calculate it, right? And that's something that I thought might be cool. So basically, this is a function that returns two answers. The one will be stored in the parameter that you send sec, and the other one will be stored in answer. Right? There's just some interesting stuff for you. That is a little bit advanced. So if you want me to just to like slow it down or to start off from basics again, please raise your hand at any stage. Or if you don't understand what I'm doing. Although sending this by ref was last term's work, so you should be cool with it. You don't understand. What don't you understand? You're welcome to put your mic on and speak to me.
Yes, sir.
Yeah, so you put your hand up when I
Yes.
said that. Yeah.
For by ref sequence.
Yes.
Yes, can you please go through that one? I don't understand. And just tell us how it works.
Okay, sure. I'll give you a quick verbal explanation of how that works. So essentially, what happens when you declare when you say by ref in the parameter list of a function, what you're saying is go to the value that comes here, go to that memory location, right? So when I declare a sequence, I'm making a little box somewhere in memory, right? So I'm making a little box in memory somewhere, which allows me to store a string, right? That's what variables are. You guys, you know that, right? So basically, what I'm saying is instead of make a new box, which is what byval does, it's go to the same box and just pull out the stuff from that box, and then put stuff back into that box, right? That's what byref means. So that when I come back here outside of the function, this box, the stuff that's in this box has been permanently changed, right? So does that make sense to you? It's like imagine you make a box for your snacks, right? And you put it in the kitchen, and instead of when you send it to the function eat, right? You usually make a copy. That's what byval does. It makes a copy of the box with the food inside. Saying byref means go to the actual box that you made the first time and actually like look at the food or take the food out or whatever the case might be. All right, I'm glad that that helped you understand a little bit. All right, so as I was saying here, um, we're going to assume that the sequence starts at 1, right? Because when we looked at the sequence, it goes 1, 4, 9, 16, 25. There wouldn't really be a problem if we started at 0 because 0 squared is still 0. So it meets the constraints to be a part of this sequence. But we'll just go for 1 because nobody really cares about 0 so far, right? So the first thing we're going to do is let's set up our loop. We know it needs to repeat 5 times starting at 1, right? So let's go for um, one. Oh wait, we don't do that anymore. That's C#. My bad. It's just 1 4 x 2 5. Let's go to 5. It's fine. We'll investigate if it actually works out, right? Because it is going to display, so it'll be easy to debug. Right now, what we know is it's going to be multiplied. So it's 1 multiplied by 4, multiplied by 9, multiplied by 16, multiplied by 25. So what I'm going to do is I'm going to demo total quickly here. All right. And what's going to happen is I'm going to say plus equals, well, not plus equals. Let's use multiply equals. Is the multiples because it actually multiplies in between each term, right? So then we'll go x times x. Isn't that what's happening here? Right? And I guess that's the function, right? Should do it. Let's make sure. Right? So here what we're gonna do is we're gonna say sequence plus equals C string, and what can we put in here? We will put in x times x plus, I'm just separating the terms, right? And we're going to return the value, the answer, which is going to be total. Let's test out our first function. Oh, well, you're not going to be able to see this. So let's first code everything. So let's code. So now you know how to tackle this kind of sequence, right? Where you have a set starting point and you know you can do it by the number of terms. The reason I put n here, well, actually we should just do n, right? So, and then because we send in 5 here, so that should be fine. So if we just put n there, it's still going to be 5. It'll still go to 25, and we should get the actual answer, which we'll calculate now. All right, so that's how to approach things iteratively. Do any of you have any questions with regards how to do that, or do any of you guys want something explained again? Line 48. I am coming through. Line 48 is the Stack Overflow will happen. Oh, we didn't get to recursion yet though. But please explain line 40. 40 is sequence plus. Okay, cool. Fair enough. That's a good question. And I do not understand 39. Okay, cool. I'll look at 39 and 40 then, just to make sure. Is that all right with you guys? Cool. So if you look at line 39, right, what's happening here is we're saying get some. Okay, let's make this a bit easier to read, right? Let's make this a bit easier to read. Because it might be a bit difficult to read, right? So what does x times x means basically is 1. Let's say x is 1. Let's say x starts at 1, right? It's going to be 1 times 1, which is 1 squared, which is 1 times total, right? But total hasn't been initialized, which is a problem. So that's why you should do design. Let's start it at 1 actually. What am I doing? Yeah, right. So why do I start it at 1, by the way? Because we're multiplying. If you use 0, anything you multiply by 0 will remain 0 for the rest of its life, right? That's how multiplication by 0 works. If you look here, what you're doing is so let's say x becomes 2, right? When x becomes 2, it's going to be 2 times 2, which is 4, which is one of the terms that we had here, right? It's the second term, coincidentally. And then you're multiplying it by the total, which was 1 from the last time, right? So now it becomes 4. So the total is now 4. Then you're saying, well, 4 times 3 times 3, right? So 3 times 3 is 9 times 4 is 36. So then the total is now 36. And eventually it's going to be 36 times 16, which I don't have the brain power to do because I have calculators. Maybe there was a time when I could do this. It's not now. Right? It's too early on a Saturday for such hard maths. Right? All right, so let's take a quick look at, does that kind of answer your guys' question for 39, right? So for line 39, with regards to the total. I'm hoping that helped you with total. Okay, cool. Now number 40, right? This is a special line. This is a little bit more difficult. You'll probably never have to use this in first year, but you will be doing this later on. Remember, recursion is such an important thing. Recursion and iteration, you will use it throughout every year of your studies. You will use recursion and iteration for I think 25% of the computer science 3 paper when it comes to trees, right? That means, and you'll be doing it on paper. You won't be doing recursion on a computer, so you can't even test it. Well, you can, but there's a way to test it, which you will learn soon. But yeah, basically recursion and iteration are really, really important concepts, and it will completely make it very difficult to get good marks or even pass if you don't know them or don't learn them now. So my advice to you is really, really take a look. If your friends don't know it, please make sure that they watch this video and that they redo the practical until they understand it. Otherwise, you guys, like, it's going to be a problem. Look out for your friends, look out for yourself. Just learn recursion and iteration as soon as possible. All right, so looking at line 40, I said you won't be using it, but I'll explain it anyway. What I'm doing is I'm building a string that takes every term. Now, how do I know it's every term, right? Well, x starts at 1, right? So the first thing that's going to happen is going to be 1 times 1, which will put into a string with a colon between, right? Then the next one was going to be 2 times 2, so I'm going to put that into the string also, which is going to be 4. So it's going to be 1, comma 4. Well, this should be a multiplication sign, actually. Yeah, so basically it's going to be 1 times 4, and then this is going to be 6, it's going to be 16, or 9, it's going to be 9, right? 3 times 3. And it's going to go in after the next multiplication sign. So that's basically all that line is doing. It's generating each term of the sequence for an n number of terms, right? Just to show you that it 100% works, we'll set this to 6 so that you guys can see it working properly, and it's not just me jippoing it to fit the problem statement. Right? Okay, cool. So you get it now. There we go. This is going to be important because I'm going to do it for the recursion thing also. That's a lot harder to understand. But let's quickly look at recursion, right? So how do we solve a sequence using recursion? All right, so we need three things for any kind of working recursion, right? We need a base case, we need a recursive call, and we need a change to conditions. Basically, the condition that we check must somehow move towards our base case, right? It must go towards the base case. The base case is really important. Without a base case, you will have a Stack Overflow. What a Stack Overflow means essentially is that you called a function too many times, right? And your computer doesn't have enough memory to deal with it anymore. And that's a bad thing. That's bad programming. Nobody likes that. You shouldn't do that. It's terrible, right? It means that your base case was never hit. Recursion means you don't have loops, okay? No loops. There are only specific conditions where we have both recursion and loops, and those are really difficult, and most people don't do them anyway, okay? So don't try and use both loops and recursion in the same thing if you don't have to. Try and find a solution that only uses recursion or only uses a loop. Actually, recursion is really fun to do because it makes your life a whole lot easier. You'll see that now, right? So this is a little joke in case you didn't get it. It's basically because this function will run over and over again, not just the loop, the whole function, which means essentially this comment is going to go into memory a lot of time, which is a pretty fun fact, right? So yeah, so again, I set out the sequence here, and I said, well, where do we end and what do we start with, right? The reason being is because this sequence doesn't exactly terminate if we start at 1, right? You agree with that? Because it can go 7, 8, 9, 10, 11, all the way into infinity, and we'll need something to stop it, okay? So for this one, we're going to specify a start and a stop, right? So we're going to start with something and we're going to stop on something. Now, this recursion in this example that I'm going to do, it's not going to deal with the term number, okay? It's going to deal with basically the actual sequence itself, right? So let's first figure out what is our base case. Our base case is going to be when this value here that we started with becomes 25, right, or over. So or the max. So if n time, why is this being so nasty? If n times n becomes greater than max, right? Then we stop. Greater than equal to, just for good measure. Okay, that's the base case. Okay, that's when we know we need to stop, right? Now the condition that we change, obviously it shouldn't be max, right? That should stay fixed. So remember, everything needs a change to conditions, okay? So what we're going to do is we're going to try and change n, but how should we change n? Anybody got an idea for me? No, please raise a hand. Promise you're probably not wrong if you want to try it. Only way to learn is to ask questions. And all right, you got somebody who wants to try. Add 1 then square. All right, let's see if I understand your solution. If I understand your solution correctly, right? So you basically saying return 1 plus n times n, 1n square, or should we add 1 to n? Maybe that's what you're saying. Return n to the power of n minus 1. N times 1. All right, That's probably the correct answer. I came a bit too quickly. I was hoping for you guys to struggle a bit. Well done. Times, yes, it's return. What did you say it was? Just check your solution out. So it's return n times n minus 1. Why did you say minus 1? I don't think that's correct. I don't think this is correct. So essentially, the reason I don't think this is 100% correct is because we don't have a recursive call also, right? An R and there we go. That is correct. And it's not negative, it is positive. Right? So we got, now here's where things get a bit funny, right? N plus 1, and it's going to be n times sequence, right? So sequence 1 rec, and there's a couple stuffs here that we need to deal with. Max is still going to be max, the sequence is still going to be sequence, right? Return n times sequence 1, n plus 1, correct, right? That's well, we'll test if it's correct. We will test if it is correct, because what we're saying here is we're saying, well, it's going to be 1 times 2 squared, which is 4 times, which is 9, then 16, then 25. So this should work, right? This should be super chill. This should be easy to do. But now to deal with the sequence thing that I said we had to deal with, right? Do you remember that? And the answer to that is we're going to, before we set this, we're going to dump a as integer a is equal to this whole thing, and we're going to say sequence plus equals string a plus, right, and we're going to return a. Makes sense. So I haven't changed what we're returning. All I've done is I've put it into the sequence each time, right? That makes sense. So we can try and test this one out also. And we're supposed to if let's just talk about this, right? If it becomes max, what should we be returning? If it hits the base case, right? That means the base case is true. Should this actually be here? No, it shouldn't. It should be below that, right? It should be below that. It should be here. And in here, we should just say return, because we're multiplying, we want to return 1, right? Because it's going to be it's going to return 1 and it's going to be times n, which is not going to change the value, right? If we hit the base case. So we'll investigate if this is correct. It should be correct. It should be. Who says this is correct? After the plus on 971, what is really happening? After the casting to string. Oh, okay. So essentially, we're just putting a semicolon in, and we're putting that into the sequence string. Remember, this is the initial sequence string that we sent. So the one that we built, the one that we created outside of this function. So that's all that's happening there, right? And return n times sequence. Well, The sad news is that is not 100% correct. What we should be returning here is actually going to be n times n times sequence, right? Now, why might that be the case? Remember 1, 4, 9, 16, and 25 are all actually square numbers, right? So that's important to remember. Okay, so we've got that going on. Let's try and start this up and test those two quickly, so that we can check how far we're going with this. Right. I'm gonna just share I'm gonna try and share the actual application that's running. All right, if this cuts out at any stage, it's probably because there was a bug and Blackboard would kick me out because of that. So just be wary of that. Don't leave or anything. I'll come back as soon as my connection allows it. Right, so let's try sequence 1 recursive, right? So this is 1 times 4 times 9 times 16 times 25 times 36. Right, remember, because I added 6. So if somebody wants to try this in a calculator just to prove that it's right, because I know it's right, but if you don't believe me, you can try it, right? So this is coming from sequence. This is coming from sequence, and this one is coming from the answer, right? So remember, it returns two things. That is a function that returns two things. Here we've got sequence recursive, right? Ooh, that's just returning 1. Isn't that a problem? Why is it just returning 1? Let's go and take a look. That means sequence is null for some reason, and we need to fix that. All right, so I'm just going to stop sharing for a while to go back to the code. All right. I'm hoping everybody can see that. I'm just closing that. All right, so this means that something happened wrong here, right? Because answer should be here, should take n, go to max, and it should return a sequence, and the answer should not be 1, right? It should not be 1. Okay, so let's take a look at what we got. We're saying if n times n is greater than or equal to max, return 1, right? That might be where we're getting our 1 from. What do I send here? N is 1. And max, oh, I don't set, do you see what happened? I didn't set max to anything. Max at 25, right? That was probably the issue. Let's start it up and try sharing that again quickly. I'm just gonna go here. All right, application window from 1, sequence 2, right? We've got 16, 144, 576, 576 again, equal to 576. What the heck happened here? That doesn't sound right at all. That looks like 4, that looks like 6 squared, this looks like 12 squared. This looks like, I really have no idea actually, but it does look like a square number. So let's go and figure out what happened, what went wrong with our little system. Let's go try a different solution there quickly. Right, let's just gonna n times n, I think, was the problem. That could very well be the case. That could very well be. We'll try to just n, and we'll see what happens. I'm just gonna go back to sharing the code quickly. All right, sorry about that. It kicked me out as I predicted it might. I'm just gonna go share the code quickly. Share application. Saturday tutorial. Here we go. You guys should be able to see my code again. So we discovered that this might be the issue, right? So let's just take away that and see if it helps. Let's try and see that out. I'm not going to switch to sharing the application. I'm just going to, I'll demonstrate that again at a later stage. 4, 12, 24, 24, answer is 24. That might be an issue. All right, so we got 4, 12, 24, 24, 24, right? And 24 being the final answer when we should be getting 25. So let's think about what's happening here, right? We've got n, which comes in as 1, right? Then it's going to be 1 times this plus 1, right? So 1 times, yeah, we're not squaring anything, are we? Try, okay, let's just look at what the message says. Return n times recursion. Oh, so you want to square the recursion thing? All right, let's try that then. I'm more than happy to try it. Let's drop a set of braces around that. And then we'll copy. And we'll multiply. And we'll try it out and let's see what happens. Here we've got 4, 4, 48, 4, 4, 48, 4, 608. And the answer becomes 21,233. Oh wait, it's actually much more than that. It is 212,233,664. That's I almost had a Zuma moment there. That was hectic. But yeah, so that's clearly not the right way to do that. Let's think about this a little bit more, shall we? We've got return. So we're saying n, which is 1, 2, 3, 4, 5, because we're multiplying by 1. So 5 times something here, right? Which is also going to be just 1, 2, 3, 4, right? So we'll get a square number. A is going to be a square number. But what's not happening here is we're not getting the sum, right? That's the problem. We're not getting the multiplication. So let's try doing it like this, right? Let's try squaring each one and then what was the solution? N times n greater than max n. So not greater than equal to. That could be a good answer. Well, I'm just gonna quickly look at give us the answer essentially. And the answer happens to be that the base case situation might be the problem. Right? So the real problem was here, which nobody seemed to have picked up. Right? So it's n times n here. Okay, that's where the problem lied, and this had to be n times n. Now, if we try it, we should get the answer. Let's just make sure. Okay, so nope, that's not what we get. I think I messed up this one a little bit. Let me think about it carefully. So this is n squared multiplied by n plus 1 squared multiplied by n plus 1 squared multiplied by n plus 1 squared, as long as n squared is not greater than or equal to max. Let's try that quickly. Nope, still gives a problem. Well, in theory, this code is correct. I'll figure out how to debug that, but we're gonna run out of time because I have to stop soon. I'm just gonna look at it one last time and see what the problem might be here. Times n, 1 times, so 5 here. What could be the issue? X is 25, 1. Try without n times n, just n Here, okay, let's try that. Nope, that just gives us hundreds, which is very weird. Even in line 64, so even at the top there. The thing with that is, right, so the max we sent in was 25, which is the square number, so we shouldn't be checking the 1 against the square number. But we can try it. I guess it just might it's definitely going to increase the number of stuff. Mm. Ooh, we got a Stack Overflow. You see, that's what happened. We ran it too many times. What if we start at the end of the sequence going towards 1? All right, how about this, right? What we're gonna do is I'm gonna come back to this. We got a system overflow here, and that's great. We'll debug it now, but I just want to show you guys the parent sequence that I pre-coded before the time yesterday, because I just thought we might run out of time, like we are actually running out of time. So I'm just gonna show you the parent sequence quickly, and then we'll come back to dealing with the whole sequence 1 recursion problem, right? So let's look at the parent function, right? So I'm showing you the simple version first, right? Which is just parent, okay? And if n is 0, return 3. If n is 1, return 0. If n is 2, return 2. And we return n minus 2, n minus 3, right? This is just the stuff that was defined on the question paper. You just literally followed it word for word, right? It gave you this whole recursive function word for word. You didn't have to do anything extra really, right? So what do I want to do with the parent function is basically here I'm going to ask for value, and you're going to give me the term, right? So I'm going to get you a term. And I created a parent b to show the difference, to show the different sequences, right? But now I wanted to show you the difference between a sequence of numbers and basically just a set of numbers, which is separated by a semicolon. So parent b adds a semicolon, but you'll see we don't get the right answer, even though the code is basically the same, right? Because we say if n is greater than 0, return 0, n is equal to 0, return 3, n is equal to 1, return 0, n is equal to 2, return 2. If it's anything else, we're going to return n minus 2 and n minus 3, right? That's that. And then we're going to just store this into a string, which should make sense. It's the way we did the sequence thing with the iterative thing, right? But it's not going to give us the right answer. And the reason behind that is because we're dealing with the sequence as if the terms must add together, right? So that the terms add together, which it doesn't. You'll see now, right? I'm just going to try and show this on the screen quickly. I'm going to try and show this on the screen quickly. All right, so here I'm going to do calc parent sequence. I'm going to just choose 14, right? Because that's a cool one to use, I guess. Right? So we'll see, and it gives us 51, right? But look here, right? So on the question paper, this wasn't the sequence. Here we've got 20203350, right? So that's clearly not the parent sequence. So I'm just gonna go back to the code quickly. as the Fibonacci? No. The parent sequence and the Fibonacci sequence are similar, but not exactly the same thing. You'll see now how to properly display the number every single value in the sequence now. As I'm just gonna so all I did was I showed you the parent B, the simple version, right? So I'm just gonna show you the code again so that you can see why it was wrong, and then we can look at that quickly. All right, so here's the code before while it's wrong, right? So the sequence is clearly wrong now, and we get the answer as parent B n sequence, right? So we don't want that sequence. So what I'm going to do is I'm just going to comment it out, and I'm going to uncomment parent, the original version, the one that I showed you at the beginning, the one without the sequence string. Now, how am I going to get the sequence without sending a sequence string to the parent function? Well, you see, the key thing is parent returns a single value. It returns a single term from the sequence. So if you put 0 in there, it'll return the 0th term. If you put 1 in there, it'll return the first term. It's not returning this function here is not returning the 0th term plus the first term, or the 0th term times the first term, like the initial two sequences, right? That's not what's happening here. It's just returning a single term in the thing, right? So we're gonna display it based on a loop, essentially, right? What we're gonna say is I got get parent sequence as a function. When I look for that, here it is. All I'm doing is I'm looping from 0 to n, and I'm getting the answer, putting it in a string, adding a semicolon. Let's test it out, right? Parent, and we'll go with 14, right? Because that's the one we're doing. Right, so here we've got the correct sequence. Here we've got 3, 0, 2, 3, 2, 5, 5, 7, 10, 12, 17, 22, 29, 39, and 51 is the correct term at the end. Okay, so this 30232, that's the proper sequence. That's how the parent sequence is supposed to look. So now that you understand the parent sequence and how to work with things that give you terms, you can now go look at debugging the original recursion one, right? So that's a cool thing to do. Let's do that. Let's go back to debugging. Sequence 1 recursion, right? Let's do a simple version, just so we know what we're doing here. Private, right? It's 1. Let's take n as integer. Let's keep doing that. We're gonna take max as an integer, and we've got e. We need to give an answer, right? I've got the function keyword. Right, so what we're going to do is let's say if n times, oh my god, I hate this, times n, which might be greater than max, right? And if what do we want to return? We want to return some square value, right? So hopefully we want to return that. So another base case is when this 1 that we sent becomes equal to or greater than 25, right? So let's just drop that like that, just to make sure everybody is, Visual Studio and I are on the same page there, right? So when this initial value, the starting value that we send, becomes greater than the max or equal to the max, we should stop. And to stop, we will return, right? And what are we going to return? We will return n star n or int n. Okay. Now that's just a simple guess, because at the end of the function, right? So when n is now n times n is 25, we want to return 25, right? Because 25 is the last value in the sequence. So we want to return 25. Because if we don't return 25, we won't get 25 in our sequence. Does that make sense? Right? So now if it's not 25, what we want to do is we want to, let's say, return something, right? So what are we going to return if it's not 25? We're going to return rexec1, where we'll send int n plus 1, max stays the same, right? Now what this is doing is we're getting, it's not multiplying by anything, which might be a problem. So we're gonna say the idea here, so the last thing that we'll get here is 25. So it should be 25 times 16, right? Which is basically 4 times 4, right? So let's just do that. Now this is essentially the same code as the last time. So if this works, I will be angry. Why didn't the first one work? Right. So we should essentially get, I think it is 14,400, if I remember. Oh, well, we're doing it with 6 now. Oh, it was 6 here. So if I remember, let's just do it with 5 in the first function, so that we know what the actual answer is, and then we can try it with 5 for the next one. Yeah, right. So where was I? I was here, rexec1, right? So if it's not there, we're gonna say int n. So it's gonna go, n is 1, it's gonna go 1 times 1 times rexec2, which is gonna be 2 times 2 times 3 times 3 times 4 times 4 times 5, which is gonna be here, right? So this should technically work. This should work, and we'll call it here at the top here, instead of displayer, we're gonna display just, oh yeah, it's uncomment here. We'll say answer was tspring rexec1 in max and sec. A sec is not going to have anything really, it's going to be a blank thing, so let's just try it out. I was going to try it out before I share it so that we just save some time. The answer is 14,400 when we do it iteratively, and the sequence gives us 14,400. So essentially what we know is that this is the correct code. The problem we were having is something to do with our string handling. Let's take a look at that. n right? What is this? N times n is equal to n times n multiplied. What did we have here? We had n times n, right? So this should be star n, right? Let's make sure the n that we're talking about is the same thing. N, cool, that works, cool. And then we get n plus 1 here. So, and then let's just uncomment the thing so we can figure out what happened. Right, start We get 14,400, and we get 14,400. But the terms are incorrect. I wonder why the terms are incorrect. I do wonder why the terms are incorrect. Maybe it's the thing we're adding to sequence. Maybe it's the thing we're adding to sequence. Let's just go and check what we're adding to sequence. We are adding A. A is this. So maybe we should just add N star N, right, to that. And let's try that out. Ooh, look at that, 16491. Yeah, that works. So the problem was actually that we were just displaying the wrong thing. Ironic, right? Alright, so you can just find out that one. Alright, so now you guys have seen how to do that. I am going to stick around for another half an hour and try and do the next two quickly with you. I'm going to show you guys that it does work. So I'm just going to show you guys that it does work quickly. Hopefully, as all right, I am back. Sorry about that. It keeps kicking me out. I have no idea why. I really have no idea why. There we go. Now we can see that, right? I'm hoping you guys can see that. All right, so here's iterative, here's recursive, right? See 16941, 14400, and it doesn't display the 25, so I'll have to fix that at some stage. But yeah, so now you see those two work, right? So where can I download the recording at? It should go to Blackboard. It should go to Blackboard, and then you can deal with that. Okay, sorry about that. It kicked me out once again. I am back though. So I'm just going to share the code, and then we're going to quickly do those, the last two, so that you guys can know what's going on with those two. If you have any questions, please feel free to take this code, take your design, go and ask the assistance lab. You need to understand recursion. You 100% need to understand recursion and iteration, right? So just a thing to remember. This one is 49, 42, 35, 28, 21, 14, 7, right? And we can see that this is a sequence of sevens, right? But remember that this sequence is separated by pluses, and pluses are commutative, right? Which means it goes both ways. Which means we can reverse this to help us, right? We can start at 7 and go to 49, which means 7 can be our first term and 49 can be our seventh term, which makes this really, really, really nice because it's basically just, right? It's just a for loop. Right? The total is just going to be really simple. So it's going to be plus equals n times 7, right? How do I know this? Because 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 28, 7 times 5 is 35. 7 times 4 is 28. 7 times 5 is 35. 7 times 6 is 42. And 7 times 7 is 49. So if we just add all of those separate terms into total, we have the answer. So we can just return total. Right, and this is 100% okay. That's the simplest way to do sequence 2 iterative. Now just to add this, the sequence, right, itself. So what we're going to do is we're just going to say in the loop, it's going to be sequence plus equals C string n times n times 7 plus comma, right? Well, it's actually supposed to be a plus, right? And we should be able to see that working. Is there a question? I think there's a question. Is it okay to use the reverse sequence in future? Like I said, plus and multiplication are both commutative, right? So this is basic maths theory. 1 plus 2 is the same as 2 plus 1, right? But 1 minus 2 is not the same as 2 minus 1. So you can't do it for a sequence that's separated by minuses. Okay? That's an important thing to remember. If it's separated by minuses, the order in which you do the sequence matters. If it's minuses and divides are non-commutative. Okay. So that's just a key thing there. All right, so I'm assuming you guys want to see this working. Should I? So, okay, let's just show you guys this working. It's probably going to kick me out again. I do apologize in advance. All right. Did it kick me out? Did it not? Can you see? You can see. Look at that. So we've got 35 plus 35 plus 35 plus 35 was 245. That's clearly not the correct one. So let's just stop sharing. Let's go to the question quickly. When I use so in this sequence, when I use step -7 and my sequence was decrementing. But that's perfectly fine also. There's multiple ways to solve the problem, right? This sequence seems to be a problem. N times 7, n is not changing. That's because n is there and we're supposed to have x here. That's what's supposed to happen, right? X is the loop variable, x. That's why that's wrong. That's why that's wrong. So we're looping with x there. That's just the thing. This is actually supposed to go to n. That's what n was for there. It was supposed to specify the number of times we move. Sequence 2 iter, we're supposed to go 7 times. Right, just so you guys can see that. I'm just going to do it again. Hopefully this doesn't bomb out. There we go. 7, 14, 21, 28, 35, 42, 49 equals 196. So as you can see, that worked perfectly, right? Just the multiplying by 7 works perfectly, but also if you decrement by 7, right? So let's say you started at, what is it, 50, what's 49 plus 7? 56, right? So let's say you start at 56 and you decrement by 7 until you hit 7. That's also a perfectly fine way to deal with this situation, as long as you hit a base case in your recursive thing, and you're calculating the actual sum of each of these terms, right? So that's just important to know when you're doing recursive functions like this, or even iterative, right? So when you're doing it in steps of -7, make sure you actually calculate what each term plus each other is. That's the only thing to worry about. All right, so back to the code quickly. All right, let's do the recursion version. That right. The recursion for the last thing. Now the recursion for the last little thing for sequence 2 is basically, it's a more simple version. All we're saying is we're going to send it some n value, and that's going to be the number of terms, right? And the base case is when the number of terms has basically gone above 7, right? That's when we're just going to return n and be like, cool, we're done. All right, so let's just sort that out. Is the recursion function. What we want to do is we're going to say if the base case is when n, which is the value we're starting with, is greater than, oh my god, I hate that. Why does it keep doing that? Greater than 7, right? For while n is greater than 7. What do we want to return? We want to return. I think we should return. What do you guys think we should return? Return 7. Alright, so we'll just return n, right? Because why do you think we should return 7 instead of n? And we'll try it. Let's see if it works out for us. And the base case is when n is greater than 7, so we'll need to increase n at some in our recursive call, right? So we're going to call it sequence 2, right? I'm just doing this in advance while I'll look at your answer now. And maybe we'll plus 1, right? And plus 1, and then sequence is going to be the same. This should return some answer to us. Maybe this is the correct answer. Maybe it's not. I don't personally think this is the correct answer, since 7 is the nth term. Yes, I understand that, but okay, yeah, we can leave it at that for now. But let's just think about this, right? So n plus 1 sec. Let's say n plus, right? Should it be n plus? Should it be n plus? So I'll leave your 7 there and we'll decide whether it's correct or not, right? It'll be n plus. So n is going to be, let's say, 1, and it's going to go 2, and then it's going to go 3, and then it's going to go 4. What do you think it should be? What do you think it should be? I think it should be, I personally think it should be n times 7 here. What do you guys think? Times 7. N minus 1, since we are decrementing. What makes you think we are, oh, so you want to start at 47, so you want to give it, so you want to give it 49 and then go backwards by 7. All right, let's try your suggestion out. We might as well. Yes, okay, cool. So we might as well try that out. If n is greater than 7 now, but remember, if we send 49 here, it's going to return 7 immediately. So we'll need to tweak that, right? So let's just say if n is equal to 7, right, return 7. So what's going to happen is it's going to go 49 times 7 plus, okay, maybe that's incorrect. So maybe we should go n times, so it's 49 plus n minus 1. Is that correct? Maybe we should go minus 7 here, right? So then we'll have 49 minus 7, which will be 42 plus 49, right? This should work. This should work, right? Essentially, yes, n minus 7. Correct. Let's try it out. I didn't do the sequence thing. We'll just do the sequence thing. Okay, wait, later. I'm just going to test to see if this works. Ooh, we get a stack overflow. So that's clearly not working. Why do you think we're getting a Stack Overflow? Let's try that. And we get 7. The answer it gives us is 7. That's not really a great thing, right? It's not. So let's try returning n. Let's try returning n and see what we get. Now we get 5. That's a bit of a problem. All right, so this was a great attempt at figuring this out. Basically, what you guys started off saying was, well, n should be should somehow diverge to 7. So n should go from 49 to 7, right? Which is fair things to say. And then we're just going to say, well, from n, we're going to say 49, then we're going to say minus 7, and it should just add up together, right? So ideally, yes, that should work, but it doesn't for some reason. And I have a suspicious thing that it's about our base case, right? So our base case is when n is less than or equals to 7. I mean, that's just for safety. What are we returning? Let's return 7 again. Let's return 0. Right? Let's try to return 0, right? Else we're gonna say, so first we start off with 49. That's what I'm doing wrong. I didn't start at 49. I started at 5, which is a weird place to start, right? A weird place to start. Uh, 491, so it's still not exactly the right answer. Maybe we could try n here. We got 486. Oh, we got a. I wrote 79. Ah, that could be a problem too. Good spot. Thank you. It's supposed to be 49 here. Let's try starting that. And we get 196. So this is not the correct answer. I will show you guys. Oh, well, let's just do the sequence thing that I've been doing. Seek plus equals string n. Right, and then there was a question. Let's go see. Yay. Yep, basically we're all done. 1.5 hours of grueling debugging. Okay, but let's just show you guys everything works out. Hopefully it doesn't kick me out again. If it does, I do apologize. All right, so let's look at this. So we got sequence 1, which works. Sequence 2, that one also works. Another sequence, sequence 1 recursively. Then we've got sequence 2 iteratively, which works. And then we've got 49, 42, 35, 28, 21, 14, 196. And it works. So everything works. We are done, ladies and gentlemen. We are done. We are done. We are 100% done. If there's any questions, please, you have like 5 minutes before I go away. Is there anybody who wants to ask any questions? No problem. I hope that was helpful. You can, one of the things I just need to show you before I go is the displayer function that I used, right? Because I used a specific displayer function that you might not have known how to build. It's just at the bottom here. It's basically just the rich text box, and I'm just adding sequence plus equals and the sum and then new line. That's all I'm doing. Right? So it's not a huge cool thing. Do we always need input box? Do we always need an input box for parent sequence? You can use a text box if you want to input the thing, but the reason the parent sequence, the way we've coded the parent sequence, right? What we've done is we've created a function that returns a specific term in the sequence. So you can't ask it to just work unless you give it a value to one of which it must return. Does that make sense? Will you please show your code again for the second sequence? Short thing coming up. Which second sequence, recursive or iterative? This is the recursive version. I'm trying to, there, you might, if you can see that, then there's both on the screen right now. So there's sequence to iterative, there's sequence to recursive, both on the screen. I hope that covers everything. You guys all happy? Does anybody have any final questions regarding this? Please watch the video again. I did cover a lot of stuff. Yes, please use your mic to speak to me if you want to, or just type the question.
Okay, so basically for the parent sequence, for the input box is for displaying like the term in the sequence, and then the actual button is for the sum. Is it how it goes, or because I had that issue, I didn't know how to go about. But
okay, so
I did like
yeah, go on.
Yes, but it was doing everything, but I wasn't understanding. I was doing it, but I was not fully understanding it.
Okay, that's a very good question then, right? So if you look at the actual practical, right, it just says calculate the nth term of the parent sequence, right? So the function you had to create returns a term in the sequence. It doesn't return a sum of the sequence terms, right? So that's why yeah, that's why we've got the base cases for 0, we've got the base case for 1, and the base case for 2, right? Ideally, you can't have 3 base cases if you're calculating a sum, because you're going to run into an issue, right? So this is for calculating a single term. In my button, what I did was I used the function that calculates a single term, and I looped through it, going from 0 to the term number that the user specified in order to get the sequence. You can do the same thing to get the sum of the sequence. You just add all of them together using a loop afterwards.
Okay.
Does that make sense?
Yes, sir. Thank you.
No problem. All right. Does anybody have any other questions? No? All right, then. Have a great Saturday. Have a good time. I hope this was helpful. Please tell your friends who are struggling with recursion and iteration to watch this, and they're more than welcome to ask any questions to the assistants, right? And if any of the assistants tells you that you're not supposed to, that the only way to solve that question was with the steps of -7 for the second sequence, they're incorrect, and tell them that they can come and ask me about it, because that's just illogical, right? So anyway, enjoy your Saturday. Have fun. Bye bye.